Hi, I'm Callista Redmond from RISC-V, and I'm here today talking with Emmanuel from GreenWaves. Hi Emmanuel, thank you so much for spending time together. Tell me a little bit about GreenWaves and RISC-V.
Hi Callista, nice to be here with you at Embedded World. So we're a fabless semiconductor company, and we have designed gap processors based on the RISC-V architecture, and taking that all the way from a core, extendable core, all the way to a very innovative SoC architecture.
Fantastic. And do you see specific applications in various industries as your first wave of interest?
Yeah, so having focused on ultra-low power, we are targeting market segments that are battery operated and that need AI at the very edge, or another way to put it is AIoT. So instead of, we're focused on markets that want to move the AI from the cloud or from the edge to the very edge or to the endpoint.
So you're looking for something with low power but processing capability right at the point of data.
Exactly.
Okay.
Right behind the sensor, we are analyzing and interpreting the scene and reducing the amount of useful information to be sent over a very low power LP1 type of a low data rate wireless connection.
Excellent. So this might be applicable with camera-based sensors or other types of things. Do you see specific industry applications as some of the early adopters?
Definitely. So vision, you're right. Cameras are the biggest usage of a consumer of AI today, and especially AI at the edge. So that's the first focus we had, and we still have, because the market is huge there, and there are many segments that we're addressing that are battery operated. But we're definitely seeing the other sensors. So microphones is something you know about hearables, of course, they are picking up. The voice is somewhat replacing visual and touch. So that's very noticeable on the market. So I'd say that's our next generation of device. I mean, the GAP 9 will focus even more than the GAP 8 on voice and audio. But beyond that, there's also other sensors, I mean, not sensors, but also sensors, not senses, such as radar,
okay.
Vibration analysis, that are not the human sensors, but that are also very interesting for AI at the edge, very edge.
Wow, so you are very much at the very tip of this innovation, and this is a new frontier. Now, why did you pick RISC-V as something to take forward in this endeavor?
Indeed, there are multiple reasons, but the openness is definitely, is definitely the prime factor, and the fact that it allows us to innovate. So we innovate at the core, we innovate all the way from the core to the system. So at the core level, the extendability of the, I mean, we know RISC-V is built from the ground up for extendability of the instruction set. So that's key to us. We are using all the new extensions that are available, and we have actually improved it ourselves. That's one thing. The other one is it allows us to innovate also at the architecture, compute architecture. We're using the PULP project, you know, the parallel ultra-low power. So that's what our architecture is based on. And above that, we're adding many other innovation on the low power, whether it's mixed signal or states, being able to you know, vary voltage and clock dynamically when as required by the algorithms. So, and let me add one more thing, is the value of an instruction. There are many instruction sets available on the market. The value of an instruction set is really also what the tools and the tool quality is. So that's a key requirement for our segments, because we provide customers many algorithms, whether they are signal processing or AI, neural network based, but also tools and frameworks to help them develop their own, starting from what the open source availability of many of these networks.
Fantastic. Emmanuel, we deeply appreciate your leadership not only in RISC-V, but for the industry. Thank you so much.
Thank you very much, Calista.